And this will calculate all of that for you, make it look appropriate, and allow you to set the depth and show it in the scene that you create. Pretty powerful. We saw some of the controls, some of the XAML features. That's the Transform 3D. It's a lot of fun. So I recommend you go get Visual Studio 2015.
And the tech preview for the Windows 10 tools.
And the tech preview for the Windows 10 tools.
Yep, have a play with it. Have a play with all this cool stuff and a lot of the other cool stuff. And when you've done that, come back and watch us look at some of the other features that you can find in the tech preview.
Welcome to the Developer's Guide for Windows 10 Preview. I'm Jerry Nixon, Developer Evangelist here in the United States. I'm here with my colleague,
Andy Wigley, also Developer Evangelist working out of the UK.
We're going to talk about some of the features in Windows 10 that you get to play with. Specifically, we're going to talk about app services, one of the neatest things we've introduced for app developers to be able to leverage.
Absolutely, yeah. So we're going to look at what are they, what's the problem they solve, look at some of the scenarios, and then just a quick look at the key bits of the code that you need to put in your app services client and your server. A few little tips about how you debug these things, because it's not quite the same as you with a regular foreground app. And then we're going to dig a little bit into some of the kind of deeper aspects of thinking about how they work and some of the things you're going to want to worry about or think about when you're building these things.
Makes sense to me. Let's get started.
So, in summary, what are the app services? Well, it just allows a store application to provide services to other store applications, quite simply. There's nothing more complex about it than that.
We should stop there.
Yeah, that's okay. That's it.
Maybe we'll explain it more.
Let's explain it more, yeah. So when you look at the whole API set, UAP, the WinRT API set, there's a lot of strongly typed APIs in there which allow apps to interact with the platform. So you can, there's the application model of contacts, there's email. So you can get at the user's contacts, you can send email and this sort of thing. And you can link to some of the built-in first-party apps with launch URI async. So you can launch the Maps app and this kind of stuff, or even launch into Bluetooth settings just by using the right URI. So it's all very flexible and all quite strongly typed and allows you to access those kind of built-in platform features and first-party apps.
Sometimes that's not enough.
That's not enough. So actually third-party apps, these kind of apps that our developers are creating and enterprises are creating to run on these devices, they also want to have good ways of having apps to interact with each other. And we have a few ways of doing that, which is these app-to-app communications techniques using URI associations, where one app registers to handle a custom URI that you've devised, like my cool app : that could be the URI scheme. And so one app could launch out a URI with using that URI kind of scheme, and the other app will be activated and can handle that the data that gets sent to it. Similarly with launch file async, an app will register for a particular file extension type, and then the sender can just create a file of that particular file extension, launch it out there, and allow the kind of the shell to route that file to a receiving app, and the receiving app can process it.
I might have a file extension of .invoice, and so I'd have an application running that handles all the .invoice. Maybe it's my billing application that can accept those.
Yeah.
It's very specialized, but maybe in my enterprise, that's what we do.
Yeah. And in Windows 10, in UAP, both of those techniques, the launch URI async and launch file async, you can specify, this is a new feature, you can actually specify a specific app is only valid to receive that. So you can have a very directed app-to-app communication. Whereas before, it was kind of, well, have we got something? Or if you had more than one, the shell would just say, well, I don't know, which one do you want to handle it?
So now we can count on the app we're trying to launch is the actual app we're launching, not somebody else who's maybe hijacked that protocol.
Right. And there's a couple two new features that are really key in this that add a load of value in this space. The first is launch URI for results. Launch for results is allowing an app to launch another one, and the launched app takes over and presents its own UI to the user, does whatever it has to do, maybe it's a payments processor or something like that, and then sends back a results package to the original caller, and the original caller finds out what the result was and then can carry on processing. So that's one foreground app talking to another So the URI transfers from the caller to the receiver. Then, the one we're going to talk about here is app services, where the calling app presents its own UI to the user, but then it can actually launch a UI-less, a headless bit of processing. What it actually does is launches the background task of another app. It can actually communicate with it, and they can handle communications between the two.
So this is terrific. A user can be using an app, never even know you're interacting with a background task.
Exactly.
And just get all the benefit for free.
Yep.
Nice. So we should think web services on a device.
That's a great way of thinking of it. Yeah, so the idea here is, just as if you're calling a web service out on the web, except these are app services on device. Yeah, so, but it kind of, we're not using HTTP to communicate with it. It's a message-based protocol, but the kind of interactions are essentially the same. It allows you to install, the user to install onto their device an app that has an app service that the client apps can then make use of.
Beautiful.
Let's look at a couple of scenarios. What kind of things might you want to do with this? Maybe a client app would just capture through the camera image of a barcode, so scanning a barcode. And then rather than every app having to find and install into it a barcode decoding library, maybe you just have an app service installed onto the device which has that capability. You just send the image over to it, it does the decoding for you, and you get the result, the data back.
That's a cool idea.
Another one, and this is a big ask for us. Maybe you, particularly from our enterprises, you have a suite of apps. So the idea is that you have a line of business suite of apps that all handle aspects of a worker's working day. So you like have a time card kind of app, a scheduling app, a NFC kind of app, and all of these things.
Beacons, perhaps.
Bluetooth beacons, yeah. Different things that all together work together to help a user get through their working day. So they're collaborating apps, all these different things, and you can implement bits of the functionality that the worker needs to get through their day in different app services, and obviously maintain them separately and update them independently. It's a great way of creating an enterprise suite of collaboration apps.
Sounds like this could get pretty complicated. What's the syntax look like?
Well, that's the good news. We've got a client B app. There we go. There's another app. There's two apps using this suite. There's this suite of background tasks. Yeah, what's the protocol? So this is a bare bones implementation. Actually, it's most of the implementation for a client. You see, I've just highlighted there. The client calls. It news up a app service connection object. And in that app service connection object, it specifies the app service name and the package family name, and then opens a connection to it. And once it's got that connection, we look at the status there. If it comes back with success, that means, yep, good, the service has been activated and we can talk to it. You might get other status back to say, oh, no, resources are short, or it's not available, or other things. But if you get success back, then you can start sending it stuff. So you use this value set, which is a new object that came out in 8.1, which is just basically a string object, string key dictionary, string object dictionary. And you can put stuff into it. What you put into it is entirely up to you. So what you're doing is you're sending a package of data over to the service, and you use send message async to do that. And if that status, if you get a success status back from that, so it's an awaitable, so you wait for the result to come back from the app service. The result comes back from your app service, and then you can carry on and do stuff with it.
I'm looking at this syntax. It feels a lot like the HTTP client. I mean,
sure.
As far as conceptually, you can really see the pattern.
Yeah, but the value set, what do you send it? You can see there we're sending in our value set three things. We're sending a key called command, which happens to have a string called calcsum in it. We've got another key called value1, where we're sending an integer over, and another one called value2, where we're sending another integer over. So you might surmise that perhaps our app service is a calculator example, which is not particularly exciting from a processing point of view, but it illustrates.
Simple to understand, yeah.
So what about the server? The service
side. It's got to receive it, right? Okay. That's the client.
So this is a background task. So it's a class. It's implemented just the same as any other background task. So it implements the iBackground task interface. And in it, we've got you have a run method, just like every other background task.
Sure.
And there's a couple of things you want to do in there. First of all, highlighted there, get a service deferral, and you kind of save a reference to that, and you're going to keep that back. You can use that later on when if you want to terminate yourself. You might be instructed by the client to do that. And then when you get activated the first time, you will be activated using this AppService trigger, a special kind of trigger. So you can then actually you can hook up. You get an AppService connection object yourself, same as the client did, and you can hook up the request received event on that. So the first time you get activated, there will be an associated message, and there will be a request to process.
Yeah.
But this is kind of the bootstrapping logic. Thereafter, your app service just sits there and waits and can receive multiple messages.
Waiting for that eventifier, waiting for that handler to handle it.
So this is where this gets different from other background tasks, which tend to be very, very short-lived things. They fire up, they do something, they have all these quotas about the kind of wall clock that they're allowed to run in a particular thing. So these are quite different. These are sitting there in the background, could be dormant a lot of the time, waiting to be reactivated. And it's all through this request received event handler. Here we go. This is what one looks like. All this is a processor. This is a bit of code that you will implement to process the value set that you've been sent. And you just, this value set, our protocol for talking to this app service has that command keyed item in it. So we just have a switch statement on that saying, okay, we've got one command called do it. Actually, the example before was calc sum. I should have put that one on, really.
Yeah.
Case do it, and then we've also got a case quit. So that the quit one is where the client, could send a quit command to the service, at which point the service will use that service deferral that it saved before, call the complete method, and it effectively kills itself. You don't have to do that. You could just leave it there, the service, and let it kind of sit there waiting forever. Well, we'll come to the lifetime in a while. It's not quite forever, but for a long period waiting for additional messages. So the idea is you can set up a chatty exchange between the two. And you send a response back, of course, to the caller. Although, actually, you don't have to. Your client could just send the package over to the service. It could do something and not return anything. It's very much
it could be a fire and forget.
Could be a fire and forget, yeah.
So how do I want to declare this. I assume it's in my manifest?
Yeah, so like most background tasks, you have a foreground app and you have to have some code in there to register it for some kind of trigger. Not in this case. So an app that has an app service, all it needs to do is put in its package.appx manifest this extension, UAPcon extension, categories Windows.appService, specify the entry point.
Now that's the namespace and class
Of the background task,
Okay.
yes, exactly that. You need very important, you must give it a UAP app service, the app service name, which in this case we called Microsoft DX-App Services Demo.
But I would call mine something unique to me.
Yeah, exactly, yes, so that's right. And that's it. It's now ready to go. It just needs to be deployed to the target and clients can start calling your Microsoft DX-App Services Demo service.
Got it. That's pretty cool.
Yeah, there's the entry point on the task and there's the name for the app service.
Gotcha.
So this, yeah, it's a very, very loose, two-way kind of chat channel. Like you said, client can send fire and forget. More usually, the client would send a package of data over and wait for some kind of response. But it's kind of meant to be used as a kind of a chatty channel between the two.
And it is a processing channel. So there's no UI on the receiving side. So it's not like you're interacting with the UI of an app like you might for an authentication or something like that. And that's not what this is. Nope. This is really a processing using a background task to do the work in its security context. That may be the most important part of it.
Yep, absolutely. Yeah, so that's the essential. Yeah, both, like I say, both client and the service can attach a request received event handler. So.
Now, I know how to hit F5 in my application and debug it.
Yeah.
But this sounds like two applications. One's a background task, one's a foreground from another app. How in the world?
Right. Well, this is anybody who's done any background task debugging will know about this, but I mention it now for those who perhaps not familiar with this. So yeah, the idea is obviously you can set breakpoints in your foreground app, the client, and that's easy peasy. Everybody knows how to debug that.
Right.
But yeah, this is like how you've got a separate project which has got a background task in it, and you want to set a breakpoint in that background service, the app service, and debug it. How do you do that? So there's two things about that, about debugging. First of all, what's the correct package family name? So the client has to specify that in a debug situation. And secondly, how you debug your app service. So the first one of them, how do you get the app service package family name? Well, obviously, if you've got a app service that's been submitted to the store, you'll have get your PFN, package family name, back when that app service is associated with the store. That's the normal way you'd get that back.
Yeah.
And you just publish that as part of the the information you'll publish about your app service that will allow other apps to make use of its services. So you'll know what it is. In development, well, the first thing to say, actually, sorry, in the tech preview is the store isn't open yet, so you can't actually do that and get the correct package family name. And of course, you're all dying to try this out. So actually, what you can do programmatically, you can find out what the kind of temporary package family name is of your client just by calling package.current.id.familyname. And that will give you back the PFN that's been given. It's derived from the GUID of the project GUID, and then it adds a little bit on the end. So the idea is just, as you can see here on the slide, there's this code snippet here. You just want to put this in the foreground app of your app service. It might be the only thing in your foreground app, because app service doesn't have to have a fully functional active foreground app. It's basically kind of just about the background task.
Yeah.
But just put this in the foreground app, run it once, there you've got your package family name. Then you can plug this into your client, and away you go.
Okay.
Yeah, the other thing is, how do you set a breakpoint and debug these app services? So yeah, like I said, people who've done background tasks will know how to do this. And you simply need to